If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. If you want to add new data, so you may be working on a data and there could be a situation where you have to add some records. Let's say for a college, you have new admissions and you want to add those people. There's some additional information that you've started capturing as part of compliance and you have to capture that. How do we add or modify the existing data frame? So there is a method called assign, which we can use. This is the original data frame, and using the method assign, we are adding a new column, which is a score. We are generating this column randomly, which is taking values from 0 to 100. Random integer, 0 to 100. 101 would not be counted, and these are 7 values that we are generating. Remember, all the new features that you add or all the features that you create on your own have to have equal length for it to satisfy a data frame. So let's just do this. So you can see there's a score column that's been generated, values between 0 to 100. And 7 such values. We can also add a column directly. For example, if a feature name is not present. So in this data frame, if you see, the features are column 1, column 2, column 3, and score. If you want to add a new feature, let's say called ID, what you can do is you can mention that name. It can be any name other than the ones that are present. If you write the same name as, let's say, a feature present in the data frame, in that case, the column 1 would be overwritten. We don't want to do that. We want to add a new feature. So let's say we want to add a feature called ID, which we are again generating using a range, values from 101 to 107, upper values not counted. Since we did not mention any step size, it took a sequence of numbers with an increment of 1 from 101 to 107. So this is an ID column. Now, in general, you may be a little worried that ID looks nice to the extreme left. These are some of the conventions we follow, right? So generally in a data frame, we look at the ID variable at the left and then the rest of the information follows. If you want to rearrange these columns a little bit, a quick trick is that you can use df square brackets. Remember, we are dealing with multiple features, so we have to use double square brackets here, not just single pair of square brackets. Double square brackets, and here mention the right order as you would want the features to appear. So this is a neat trick. Your original order was this, but you want the ID to feature first, so you can give the order as you would want it and just get the output. So ID column came first, and then rest of the information follows. You may be wondering that we sometime back added score, but score doesn't seem to be continuing here because we added score to a different data frame. The name of the data frame was df assign. That's why it is not a part of the original data frame. This addition we did here is to the original data frame, and that's why ID column continues to be here when we print df or when we look at the output of df. Likewise, to modify the values within a column, we have a replace method. And let's say we check the data type for column 1, the data type is integer. Let's say for this particular column, there's a value that we want to change. I'm just messing it up. So a value 5 here in the data frame, we want to change it to the string 5. And we want to do this change in place. Notice if I don't write this in place is equal to true, which is an attribute, it would just give us a view with 5 displayed, but it would never affect the original data frame. When we write in place is equal to true, the change is going to take effect to the original data frame as well. So let's just look at this column now and also check the data type of this column. So it's giving a warning which says setting with copy warning. A value is trying to be set on a copy of a slice from the data frame. We deliberately are doing that. But interesting thing I wanted to show you is that because of that one value converted to 5, let me show you first how it got converted. Let's just write df here and see if it got converted or not. So if you see, the value 5 appeared here, right? Because of that one change that we made, the data type of this feature has changed to object. Why? Because earlier it had all numbers, integers to be precise. In fact, at later stages, we'll be using this a lot to figure out if a column has values which are not intended to be there for that column. For example, let's say you're studying cars and you're studying mileage. And it shows that the data type for mileage is object type. Now we know mileage is supposed to be a number. It cannot be an object. It would simply mean that it has some entries, could be some garbage entry, say a question mark or some special symbol, which is making it an object. So one of the important checks that we'll be doing later. This warning can simply be ignored. Python just didn't like the idea of us modifying the data frame the way we did. So that's fine, because I wanted to convey a point that the data type of the specific variable, which was integer, would change to an object. We've already seen lock and ilock indexing. We can again filter the data frame using lock and ilock and do appropriate modifications. So let's take the data frame 1. And for this data frame, what we're doing is we are just filtering the values where the age is greater than 23. And for those people, we are changing the site to Seattle. See what is happening. So based on one variable, we are filtering the data. and we are modifying another variable. So we are saying all the people who have age greater than 23 are supposed to be moved to Seattle. So let's see what happens when you look at the data frame. If you see, these two individuals had age greater than 23, and their site or location has now been changed to Seattle. That's the change. If we want to apply specific computations or functions to our data frames, we can also do that. For example, let's say when you started the organization, you had very limited employees. So you went ahead with some basic employee ID function and you had everything in sequence. But now you have maybe 10,000 plus employees. So you want to change the way employee IDs appear a little bit. How we can do that? We take the employee ID column and we are applying a lambda function to it. Now, lambda function does not require a body. It does not require us to use the keyword define and return. All we are saying is that whatever is the value of ID here, let's call it an X, and add 10,000 to it. Just a simple modification. And what are we doing? We are storing it back to the same column. So this time you're overriding the existing column in the data frame. Employee ID column, the earlier one, would be modified like this and will be stored back with the same name. This is called overriding, which is fine because we know it. Done. Earlier, the employee IDs were 101. Now it's 10101, right? That's how it is added 10,000. We can also add new rows or columns to a data frame, and we can conveniently do that using concat, which is again a method available in Pandas. So let's create a new row. Let's say we have a new employee with an employee ID 10106 and age is 24 years who has joined the site B. So this is a new record. One important thing is if you're passing these numerical values, even a single value that you're trying to introduce has to be put with the square brackets, just like the way you do it for list. For categorical variables, it's fine even if you don't put it. But for numerical variable, you have to put it in these square brackets. So we have a new row, and what we're doing is we're doing concat to the original data frame called df1. This new row, this is a list that we created, and we're writing ignore index is equal to true. Okay, let me not do ignore index is equal to true and then see what happens. You'll see its consequence sometime later. Let me just remove this for the time being. Observe the index values carefully. If you see, it has 0, 1, 2, 3, 4, and then again 0. It has not really added this value with a proper index in sequence. That's the reason we used ignore index is equal to true. Let me just introduce it back. If you write this now and rerun it, see, now it's saying 0, 1, 2, 3, 4, and 5. So ignores the index of the record being appended and puts it in sequence. That's how it is. Now, let's say we have some kind of a review for these employees who were hired, and we have evaluated their profile and we have assigned a profile score, right? So what we are doing is that we are generating some random values using NumPy, and we are generating how many values? We are generating 6 values, but because this is a random generation, we've used a seed here to ensure that we generate the same value every time. So when we run this, this is a new column, which we're creating like a data frame with one column. Actually, it's called a series, and this is a profile score. Now we want to add this column. Last time we added a row to the data. Now we are adding a column to the data. So how do we do that? We simply have to change the axis to 1. This data frame, what is df2? df2 is the modified data frame where we had a new record. To this newly modified data frame, we are adding a new column as well. But this is a column, so we'll mention axis as 1. When it was a row, we did not mention axis because by default, it is 0. Let's run this. So you have a new column called profile now. We have created a detailed video on handling missing data, but there are a couple of basic methods in Pandas which are capable of handling missing values. This is not an exhaustive list. Some of them would be related to just applying a forward fill or a backward fill, or maybe just fill NA. So we'll quickly talk about these. So first, we know this is the data frame we created some time back where we introduced 4 missing values. And let's say we want to drop the missing values. That's one of the treatments. We saw that already. If we do drop NA, it's going to drop the rows which contain missing values. But this is not a practical option if you have too many rows containing missing data, right? So we may want to do a specific kind of a fill, and we have a method called fill NA for that purpose. Likewise, we have a forward fill, backward fill. You can check more on these in the documentation. Let's say we want to replace all the missing values wherever we encounter them with zeros in the original data frame. So df with the null at these 4 places where we had missing values, and we want to replace them with 0. If we do fill NA with a 0, it replaces these values with zeros, right? Not the best treatment. And like I said, we have a dedicated video on very advanced missing value treatment that you can check. We can also do aggregation or grouping on the data. For example, let's say we take the data frame 1, which has these values. And let's say we want to get some information with respect to the site, right? So we want to understand what's the average age of the individuals at site C or A or B, or let's say the youngest team member on a given site and things like, or the senior most team member on a given site. We can do all that through aggregation functions and various other functions. So first of all, we can do a group by typically on a categorical variable. So we've taken the variable called site. We are grouping by the site, and then we are applying various aggregation functions here. So how do we do this? Let's say we want to do a sum of age. A lot of times they talk about collective experience of people attending a training or a group. So they do a sum. They say total these many years of experiences here. So we can do a sum on what? So this grouped is the object that we got here. We are saying we want to now refer to the age column and we want to do a dot sum. So this will be printing the sum of the ages for each site. Likewise, this will print the average. This will print the maximum. This will print the count of occurrences. We can also get through. This will print the count and this will print the variance. You can also change it to standard deviation if you want a standard deviation of variance. See, this is printing the sum. A, B, and C were unique entries. But for Seattle, there were 2 employees greater than 23 years of age who were moved here. That's why the sum value is showing as 52. This was just the mean. So this is the average age. Seattle has a higher average age because people above an age were moved there, right? So you have that here. And likewise, next was max, count. And so what is the maximum age? That will be mostly applicable for this variable called Seattle only, because for all the other places, we had just one unique entry. So maximum, minimum, when you have just one entry is not very meaningful. But if you have multiple entries, you can take the maximum. This is the count thing. And when you take the variance, this one smartly says nan for the constant values. When there's just one value, there is no question of a variance. When you have at least 2 values, you can calculate the variance. That's how it is. Now, important thing is, if you want to use a custom function, there could be times when you're doing specific calculations and you want to derive some custom metric out of it, you can use that also along with this grouped object. So grouped object we created some time back. On the age, let's say we are saying we want to calculate the range. So we are taking the difference between the max and minimum. And this is a function. So if you see this as a proper defined keyword, we have a function name. It takes an input, which is, let's say, the age, and then it returns a difference between the maximum and minimum. This is a proper function. And a lot of things that we've been using so far, like, for example, this aggregate or that info, all those were methods. Those were connected to an object. Here, a custom function is being applied through what? Through an aggregation method, and we can see the result. So it's calculated the difference. Now, wherever you had just one observation, there's no question of a difference between minimum and maximum value. So it returns a 0. But wherever you had different ages available, it's taken the maximum minimum value difference and it's returning it to. So this pretty much covers the basic methods that we need for our day-to-day usage in Pandas. When we're dealing with data frames, we would be requiring a mix of these, not necessarily all of these, but these come handy. So it's good to be comfortable with these functions and you must practice these along. Hope this helps. Thank you.